The goal of this video is to show you how to go from a real-world data set towards using R code to analyze the data. And I think the reason I'm doing this video is because some of you reported having difficulty with importing data from external sources into R. So I hope by making this video I can show you the process I'm usually using, and also another reason is to show you how you can collect data from Twitter, for example, using a very interesting tool called NodeXL. So let's start from here. So the website you're seeing, it's called NodeXL. It's one of the popular social network analysis tool based on Microsoft Excel software, and I didn't really spend a lot of time using it. But however, you can find out there are many different data sets already collected online that are shown in the NodeXL graph gallery. And for example, many of them are from conferences. For example, you can see there's a CSCW 2015, which means Computer Supportive Collaborative Work, one of the research field I am not directly connected, but I know of. And there are other things like digital learning. I don't know what conference that is, but maybe it's another Twitter hashtag people use to discuss on Twitter. So there's many interesting data sets out there you can explore or play with for the class purpose. So the video, what I'm going to do is, for example, if you click on the CSCW dataset, you can see there's already interesting visualization there and some very high-level overview of this dataset, like how many Twitter users are included and how many, for example, there's some overall metrics of this graph. So quite interesting, and different kinds of URLs. There's some groups. So you can play with it and find out more about this tool. But the purpose of this demonstration is, if you drag down to the bottom of this page, you can actually download the data, the graph data, into a NodeXL workbook. So let's do that. So after it's downloaded, then after you open it, what you will see will be something like this. It's an Excel sheet or Excel file containing many different sheets under it. And what you see here, it's the sheet of vertices, but there are many other things like time series. If you're interested, you click into it to see, and maybe it's a visualization of activities across time. There are other things I didn't really play with a lot, but there's another important sheet called edges. Just like when you are trying to organize your data, usually you have a table or a sheet of edges, and you have another table with vertices or nodes, and it's exactly the same as we were trying to accomplish when you are trying to collect data. So right now it's one of the kind of real-world data we just got from online, and what you see right now, it's very standard table format. And however, as you can see, because it's Microsoft products, you can see there's a lot of additional information here. For example, there's formatting with regard to the background color, and there is an additional row up there trying to add some kind of additional information about, for example, from here there's information about graph matrix. If you go to the vertices page, for example, you have another thing. It's actually an image embedded in a cell, and you can see there's additional row up there as well, talking about just describing these columns about graph matrices. So this information actually violates the tidy data principles I mentioned. So if you want to import this data to your either SCAFE or importing into R, you need to do some cleaning. to begin with. And very straightforward thing, for example, is to remove, for example, this row is definitely need to be removed because R will treat it as the first row of the data, and then we'll treat it as the name of the variables. So they need to be definitely removed. And another thing is to identify those information you need for your analysis. And so for social network analysis, what we need basically for edges is just the source of the connection or the tie and the target. So vertex 1 and vertex 2 basically is what you need from this data set. You don't need those information about, for example, the link to the author or some of the many other columns that contains information you don't necessarily need for this specific analysis. However, for me, I'm interested in this column about the vertex 1 and vertex 2. I'm interested as well. I'm also interested in relationships because there are different kinds of interactions on Twitter, including mentioning somebody or directly replying to somebody. And there's another column which is about the date the tweet was posted. So I want to grab those four columns and copy it, and then I want to create a new Excel file, then paste those over. So after I do that, you realize the first row is empty. So the next thing I'm going to do is to remove that the first row. And also this, the title of the column number D is a bit too complicated. So I'm going to simplify it to just to date. And so to this point, you see what I have is actually 4 columns. How many rows? Let me see. 319 rows. It's not a huge network, but basically it has necessary information that I need to construct a social network. I have the ID of the Twitter users, the relationship types, and the date. And what you can do next, either no matter whether you're using Gephi or using R, is to import this data into your environment and start to play with the different network analysis techniques. So because Gephi, I think it's pretty straightforward. You can import a spreadsheet and you can already have the data. You can do the same kind of exploration with visualization, different layouts. You can calculate those metrics you have been playing with. So for this video, I'm going to focus on R because that's where some of you were having trouble with. So, but if you have trouble with Gephi, feel free to post questions on Slack, and we can try to debug or try to find solutions. So here we are in RStudio, and before I talk about this specific dataset, I want to mention a few things. First thing is, I know some of you are coding or doing this assignment using the R standard R installation, which is different from RStudio you see here. This specific software is called RStudio. It's one of the R tools people use, and I think it's right now the most popular one because it comes with many different and different kind of additional features that many people design to improve the R experience. So if you're not using RStudio, the first thing to do is to install RStudio and get it up to running. And the second part I want to mention is I know some of you are doing codes, for example, in this console. It's where you write your code, and I think one of the video from another professor was also using console. And for example, you can say x equals 1 plus 4, and then you can see x is 5. So this is great. You are doing that, and however, I want to recommend you when you are trying to write your code, try to write your code in a separate file, which you can actually create in RStudio by clicking on here and then there are many different types. But to begin with, I want to encourage you to do the R script. So if you click on R script, it becomes an empty file. And what you did in the console, you can say R equals x equals 1 plus 4 and x. So you can actually write in here. And the reason I recommend doing this is because what you write become recorded and it become reproducible, because what exactly you write is part of the history you're trying to put into this file. And then you can choose to save it to somewhere you want, and so you get a copy of it, so you don't lose your work in case R crash or whatever happens. So when you're in this file, you can do something like you run, and then the line your cursor is the R will execute that line. And if you put your cursor here, you press run, and then that line will be executed by R. So that's, I think, recommended way to do your work in R. And if you're not started, and definitely get started, and I think it's a much better experience than you're trying to find out which role, which R code it executed, and in case you forgot, and later on you need to find out from somewhere else. So that's kind of a meta comment on using R and RStudio. And for this graph, for this specific network data, and what you need to do is, like I said, I'm going to write my code in this file, and I already did something. I played with a bunch of things already. So let's just walk line by line to make sure that you can also follow through, and you can add additional interesting analysis into this file and share back to the class. So the first thing you will notice, the first line is a comment. So whatever line starting with this symbol will become a comment, no matter whether it's one symbol or 2 or 3 or 100. It's a line that will not execute, and it's a line that R will treat as a comment. So I will use this line to make notes either to myself, so I remember what the code are about, and also those notes could be useful for you or my collaborators, so I can share the code to my collaborator, and they will understand what I'm trying to do. So what I actually wrote in this file is quite minimal, but in other cases, in more complicated projects, I write pretty extensive notes, especially for those computation. Those are, in case they're more complicated and easy to forget, I will put more notes here. But here you can see the first is about, this is a lab for week 7, and the first part of the code is about reading data from Excel. And there are many ways to read data, and the way I did was to use one of the R library called read Excel. And so if you haven't installed that one, you can do that by going to Tools in RStudio, and then click on Install Packages, and then if you search read Excel, then it's one of the packages you can choose from, and then you can just install. So that's another benefit of RStudio is you can install packages pretty easily from its own interface without getting into the command line interface of R. So let's run the code line by line. So the first thing you're going to do is you're going to load the library by running this one, and the second thing you're going to do is to read the Excel file by using this function from the read Excel library or package, and it's similar to when you're reading a CSV file. The only parameter, the only information you need to provide is the path of the file. And if you are having trouble with understanding what does path mean, you can search more about that online, especially because it's hard to define it because I'm using Mac, it could be different if you're using Windows. So it's hard for me to give specific instruction to everybody. But if you have a question about a specific platform you're using, you can always ask. And what I want to mention here is what I provide here is a path that start from the present working directory, and that's pretty complicated. I mean, the term is complicated, but what it means is if you try to get the working directory, you will see this is the directory I'm currently in when I'm using R. And what I mean just by saying that sentence was the path here would be starting from the working directory I'm currently in to go down 2 levels, and then I can find the specific file. So I hope that makes sense. If it doesn't, feel free to ask in Slack. So next thing we're going to do is just run this line, and then you can see the file which was saved, basically this file, was read into R, saved as a variable called CSCW. And let's check what's in there. And you can see it's exactly what you saw in the Excel file. And so the data is in here, and it's a tidy data set because each column represents one variable, and each line represents one case. And so we can do many other interesting things after we get the data in here. And the things include, for example, if you want only focus on the connection or the ties of mentioning, then you can actually filter those other tweets of other different relationships. So, or you want to narrow down to the first week of the data. So starting from February 16 and ending until February 23rd, you can do that as well by just filtering or slicing the data based on whatever criteria you're using. So those could be interesting and useful for you if you want. For example, I did one thing here is to only grab to get those connections with the relationship of mentioning. So if I run that one, you can see I get a new data set, or a subset of the data, original data. Then they can do additional analysis only using this slice of data. So that's more kind of general information about R and dealing with data in R. And then from this line here, we're going to dive into more specifically social network analysis. And the first thing, as you have been doing already, is to load the iGraph library. And then it has been loaded successfully. Then the next thing is to read the data we had into a graph, in the graph object. And I use this function called graph from data frame. And if you, for example, if you don't know about it, one way to find out is to use question mark the title of this function and press enter. Then this will pull out the kind of help information about the specific function. And you see that function is here. It tells you that it has 3 different parameters. The first one is called D, and then you can read further down here. The D means a data frame. And what need to be in the data frame is the first 2 columns need to be basically the source and target of the ties, and other columns are all treated as attributes of the edge. So what we had in the table here is valid, or it adheres to what iGraph requires. So that's good. And so you can see here the line. What I did was to read into the CSCW data set, which I created from Excel. And then secondly, I kind of specifically define it as a directed graph, and to set this one as true. So if we run this line, the graph will be created, and there's a warning information that you do not need to worry about, because warning doesn't mean it didn't run. It means something might be wrong, but it doesn't. Still, the line was executed successfully. So, and you can do some more further exploration. For example, you can get, okay, I want to check what's the attribute of all the edges in this graph, and then you can get it. So the attribute, first one is relationship, like you saw in this file. Basically what you see here is information from this column, because these two columns were read into R as attribute of those edges. So you can check there are many attributes about the relationship, and the second attribute is about date, that get translated into this graph data set. And what you realize that the date in Excel is a more kind of standard format of the date, versus here is a long, large number. And that's something you can kind of more also standard R use those integers to represent a date, instead of a more kind of a character or the date format we encounter in daily life. Just FYI, and you can always translate this integer back to the format we had in an Excel file if needed. So, so far for this demonstration, we have got the data into R, and we have created a graph object that we can further analyze using social network analysis techniques. So let's do some really quick and simple analysis below, just to demonstrate what you can do from here. I think you have done a lot already, and I don't want to spend too much time from this point, but I want to walk you through some analysis that you can run. For example, first then you can do a plot, right? And there's a lot of warning because it's probably a large data set, and you can see it's not readable at all. So let's zoom in. You can see there's some interesting clustering happening already, and you can further try to make it more readable by tweaking the arguments or parameters of the plot function. And I don't want to dive too deep into here. And the next part of the analysis first is the network level analysis. What you can do first of all is to calculate the density of the graph. So using the default setup or default arguments, get that the density is actually 1.5%. It's not very dense network at all. And the second, you can calculate the diameter of this network. It's 5. That basically means from this point to the other point, the distance, the number of jumps you need to make is 5. And cohesion, another parameter, is 0. So you can do many things on the network level. By just running one line of code, you can get back the value that represent one aspect of the complete network you're analyzing. And again, we save this code into this file so that you can keep the history and you can share with other people, with your collaborators, or revisit later. Or later on you decide to do it differently, you can always come back and edit. So make everything more reproducible and easier to manage. Let's move on, and the next part is about the node level. And just like what we did for the network level, you can use, for example, this line of the code to calculate the degree of every individual node of this network. So let's run this line. And you can see here what it returns is a list of values. and each value each value is mapped onto one individual Twitter user. So, for example, this specific Twitter user had a degree of 2 versus this one had degree of 1. And there might be some other Twitter user, for example, this one had a degree of 14, so more connections and maybe heavier edges connected to this person. So you can actually get this information by using this line. And similarly, you can calculate between its centrality in this graph by running this line. And you can see here this person has a degree centrality of 16, which is, I think, pretty high. This person has a even higher centrality, versus many other people has a centrality of 0. So it's another measure you can get from iGraph. And more related to this week's topic, you can see we can do components, right? We can identify how many components are there in this network by running this line, and you see the results are components membership. Basically, for every individual node, the number under that node represent the membership of that specific author or Twitter user. And for example, if you drag down, you can see there's a value of even 1720. So let's see how many components in total have been identified. And it's hard to count, but this is 26, 7, 8, 9, 30, 31, 32, 33, 34, 35, 36, 37, 38. So in total, 38 different components have been identified. But you will realize the first component is the largest component. It's a component that has 90 different nodes connected to each other. So in this way, right, this 38 is right here. I actually didn't need to count by myself earlier. So you have 38 components in total. The largest component is 90. So probably you want to do some additional analysis of the large component in networks further. But I don't really need to do that right now. You can do a bit more exploration and try to find some tutorials online to do that. So for the next part of doing click analysis, similarly, you can do you can run this line to find the clicks of the network. But in the meantime, you can also find out what are the largest clicks in the network by running this line. And what it returns is actually two. You can see there's one component here and there's another one here. Basically, it find out there are two largest cliques with 6 different members in that cliques, and you can see there are those people, and then they're talking with each other a lot, and are directly connected with each other. So in this way, you can identify cliques using iGraph pretty easily. And for the other concepts like N-cores, M-cores, or N-cliques, or keyplex, those different specific techniques, you can find more online by searching or by reading the iGraph documentations. I hope you can find more information about it. But I think for this demonstration, I hope it's useful for you to kind of think through the process of starting from the data set we got online here, or a different data set, and then try to clean the data set a little bit. It's not a substantial cleanup actually, but clean that up and organize the data set into a tidy data set, and then read the data set into R using a specific library, and then to create a graph object and do some plotting, do some additional analysis, and make everything documented and reproducible. So I think that's a major purpose of this demonstration video. And yeah, that's it. I think for this week, I hope you can just build on the code I have here and expand and go to details and set up those values and parameters so that you can achieve specific purposes of your network data. So this is just for demonstration, really simple things I had here, but you can tweak the parameter to serve your specific research purpose. And again, the code I walked you through is online, and I will post the link on our course website as well. But you can see what I saved in my file is also here, so you can actually copy and paste into your RStudio and start working from there. And again, I hope this is useful. Let's get in touch online.